Hi, everyone. My name is Dr. Zahid Khan. I am currently serving as an associate professor in the Department of Mathematics and Statistics at Hazard University. My research interests include statistical quality control, Neutrosophic statistics, and the development of statistical methods for handling uncertainty in real-world data. Over the past several years, I have been working on different aspects of Neutrosophic theory and its applications in statistics, decision-making, and quality control. Today, in this lecture, we will explore the basic idea of Neutrosophic statistics and see how it helps us understand and analyze data when uncertainty and indeterminacy are present. We will discuss Neutrosophy in action, focusing on how Neutrosophic logic and Neutrosophic statistics help us understand and manage uncertainty in real-life decision-making. In many fields such as healthcare, business, and social sciences, decisions are rarely purely true or purely false. Instead, they contain elements of uncertainty and partial knowledge. Neutrosophy provides a framework to deal with these complex realities by incorporating truth, falsity, and indeterminacy simultaneously. Neutrosophy is a philosophical framework introduced by Professor Florentine Smarendake. It studies the interaction between three fundamental components: truth, falsity, indeterminacy. Unlike classical logic, which forces us to choose between true or false, Neutrosophy recognizes that real-world information may contain all three aspects simultaneously. For example, if someone claims a medicine is effective, a classical thinker asks whether it is effective or not. However, a Neutrosophic thinker asks three questions. To what degree is it effective? To what degree is it ineffective? And what part of the situation remains uncertain? For centuries, classical logic has guided scientific thinking. It assumes that every statement must be either true or false. This approach works very well in mathematics and computer programming, but becomes insufficient when applied to complex real-world situations. Real-life problems often contain contradictions and incomplete information. For instance, a teacher might be excellent at explaining concepts, but weak in classroom management. So, is the teacher good or not? Classical logic cannot comfortably answer this question. Neutrosophic thinking allows us to represent the situation more realistically by acknowledging partial effectiveness, partial weakness, and some uncertainty. Many aspects of life operate in what we can call the gray area between truth and falsity. Human emotions are rarely simple. A person may feel excited about a new opportunity while simultaneously feeling anxious or uncertain. Similarly, in the digital world, we are constantly exposed to conflicting information. Some sources support an idea, others contradict it, and some remain neutral. Even social relationships contain mixed elements such as trust, doubt, and evolving expectations. Neutrosophy acknowledges that truth, falsity, and indeterminacy can coexist simultaneously. Rather than creating confusion, this perspective actually provides a more complete understanding of reality. Neutrosophic thinking can also be applied to everyday personal decisions. For example, when choosing a life partner, a person may feel a strong emotional connection while still having concerns about long-term compatibility. At the same time, the future remains uncertain. Similarly, relocating to a new city may offer career opportunities while creating family challenges and uncertainty about adaptation. Educational choices also involve multiple factors, such as passion, skill, and unpredictable career outcomes. Even friendships may contain both strong emotional value and damaged trust. These examples show that personal decisions rarely follow a simple yes or no logic. In the business world, decision-making frequently involves uncertainty and conflicting evidence. For instance, during hiring decisions, a candidate might demonstrate strong potential but lack direct industry experience. Managers must evaluate both strengths and uncertainties. When entering new markets, companies often see growth opportunities alongside economic risks and regulatory uncertainty. In conflict resolution, different teams may interpret the same situation in completely different ways, making it difficult to identify a single truth. A Neutrosophic approach encourages leaders to recognize these complexities and make flexible, transparent decisions that consider multiple perspectives. Healthcare is another field where uncertainty is unavoidable. Medical diagnosis often involves incomplete information. Laboratory tests may suggest one condition, while symptoms point toward another possibility. During pandemics, health authorities must make decisions based on evolving data. Transmission patterns, vaccine effectiveness, and behavioral responses can all introduce uncertainty. In sensitive situations such as end-of-life care, doctors and families must weigh short-term survival probabilities against long-term quality of life. Neutrosophic thinking provides a structured way to incorporate uncertainty into these difficult decisions. Neutrosophic statistics extends classical statistical analysis by explicitly incorporating uncertainty into data representation. Instead of assuming that every observation is precise and reliable, Neutrosophic statistics models each data point using three components: truth, representing reliable information; falsity, representing incorrect or contradictory information; indeterminacy, representing unknown or ambiguous aspects. By incorporating these three dimensions, Neutrosophic statistics allows researchers to analyze data while acknowledging uncertainty rather than ignoring it. Neutrosophic statistics is particularly useful in data analysis and quality control. For example, in survey studies, respondents may answer yes, no, or not sure. Traditional analysis often ignores uncertain responses, but Neutrosophic statistics allows us to include them explicitly. In manufacturing, product measurements sometimes fall into an uncertain range due to instrument limitations or environmental variations. Instead of immediately rejecting or accepting these products, Neutrosophic analysis allows for intermediate decisions, such as retesting or further inspection. This leads to more flexible and realistic quality management. To conclude, Neutrosophic thinking encourages us to embrace uncertainty rather than ignore it. It reminds us that uncertainty is not a weakness of knowledge, but a natural part of complex systems. By recognizing multiple truths and acknowledging unknown elements, we can make decisions that are more transparent, flexible, and adaptive. In a world that often demands certainty, Neutrosophic thinking gives us the intellectual courage to admit that some aspects are known, some are unknown, and some may remain indeterminate. For those who are interested in exploring this topic in greater depth, I encourage you to study the conceptual foundations and step-by-step development of these ideas in my book. The book provides a clearer pathway for understanding Neutrosophic logic, Neutrosophic statistics, and their practical applications in real-world decision-making. If you'd like to study the subject in a more structured way and gain a deeper understanding of the concept we discussed today, you may refer to my book Neutrosophy in Action, Real-Life Applications of Neutrosophic Logic and Statistics, which is available on Amazon. Thank you for watching.